Right, thank you for sticking around for this talk. I hope you haven't fallen asleep reading that title there. We're actually thinking of calling it Getting the Trino Bunny Drunk with Pinot, but we thought that wouldn't have been accepted here. My name is Martin Traverso. I'm one of the creators of Trino and CTO at Starburst. I'm here with Elon. He's an engineer at Starburst. He joined recently, but he's been working on the Trino ecosystem for many years, ever since we were at Facebook a few years ago when we created Trino. By show of hands, how many of you have heard of Trino? Oh, that's a pretty good number. OK, so that will make it much easier. I don't have to go over what Trino is. So I assume everyone here is a Pinot crowd, so you all know that Pinot is really good at dealing with low latency queries, high volume, and it does that with a set of technologies around fast indexes, and it's also good at doing low latency ingestion. So it has a set of capabilities that are pretty unique. On the other hand, Trino is a SQL engine with advanced analytic capabilities, and it allows users to connect to multiple data sources, get data joined together in a single query. So you can think about combining, if you combine those two systems, you can actually get the best of both worlds. You can get fast queries, low latency, and all the whole power of Trino to do very complex and advanced queries. So for example, you can take data that's in Pinot, you can join it with data from other data sources. Let's say you want to bring in dimensional data that's in Postgres. You can bring all that together and do further analytics. You can also simplify your data management by, for example, if you need to move data from one system to another, say from Postgres into Pinot, or from Iceberg or Hive into Trino, or vice versa. You can use Trino as an interface and do that type of manipulation. And of course, because Pinot is fast, you can do analytics very quickly. So let's dive a bit more into how this works under the covers. So Trino has a connector architecture, as I mentioned. And this is one of the key features, defining features for Trino. Ever since we created it at Facebook about 10 years ago, we added the ability to have connectors. That made it possible to run a number of different use cases, all the way from interactive and batch analytics over the massive data warehouse that we have at Facebook, to an analytics backend for user-facing applications, or the analytics backend for the A/B testing framework that Facebook had at the time, or even a SQL analytics front end for custom data stores. For example, the systems behind the feed in Facebook runs on a custom data store that's in memory distributed. With Trino, there was a connector that we implemented, or someone implemented, that allowed you to run queries over that data store very quickly. So as long as you have a data source and a connector that can expose that data in that data source as tables, that is metadata that describes the tables in terms of columns and types understood by Trino, and then it can serve that data to Trino at different stages in the query. Trino can access that data. You can query over that data. You can use the full power of Trino SQL over that data. And connectors do that by implementing a set of interfaces. There's a metadata API that a connector can implement to provide that information. There's a set of APIs for providing statistics about your data that the query optimizer in Trino can use to find the best plan for executing that query. And then a set of APIs for figuring out how to access that data and getting the data as a stream of data in a format that Trino understands. So we have about 25, 30 connectors that ship with Trino. That includes connectors for Hive, for Iceberg, MySQL, Kafka. There's even a connector for Google Sheets. So it's actually pretty straightforward to add a new connector. One of the connectors that we have that we added a couple of years ago, actually Elon implemented most of it, is a Pinot connector. So it's a connector that can reach out to a Pinot cluster and fetch metadata about tables, fetch data, and that makes it possible for Trino to run queries over that. Then in terms of the capabilities that you get out of Trino, like if you're combining Pinot with Trino, you can do all these advanced SQL analytics. First of all, you can do everything you can do in a analytics OLAP database, managing tables via insert, update, delete, or merge, which is a function that combines everything. You have function libraries, for example, a rich set of JSON functions. We implement the functions in the SQL specification. There's actually a new specification coming out soon that enhances that, and we're planning to add more to that. And then geofunctions, like you can deal with coordinates and area and shapes and compute areas and perimeters and all that, intersection of shapes and all that. Basically, what you would use if you're doing any mapping applications. So that's a pretty complete set of interfaces. And then, of course, if you're used to using advanced features in SQL, we have all the classic ones, analytic window functions. We have a new feature we added recently or last year called pattern recognition or match recognize, which allows you to analyze events and sequences of events and detecting patterns in those events. This is pretty unique. Not many databases support that, so we have that in Trino. And of course, if you're running on top of Pinot, you can get advantage of that. Grouping sets as a more sophisticated way of doing aggregation queries. And then more advanced queries that if you need to do more complicated things like correlated subqueries and so on. And then because Trino also supports fault-tolerant execution, if you are running queries that take a long time, especially if you're joining data from, say, Iceberg or a data lake scanning over terabytes or petabytes of data and joining against Pinot, you can combine those and take advantage of the ability for Trino to recover the execution if something fails along the way. So you can have your queries run to completion, not have to expose users to failures and have to retry on their own. So in the rest of this talk, now Elon is going to talk about some production use cases for running Pinot with Trino. He's going to talk a bit about how the connector works under the covers and some of the features the connector has, and then he's going to give us a demo of the two working together.
Hey, oh, good, it works. All right, so we're going to do a live demo, but I'll just go over some use cases. So importing data, one of the things I was going to show is you can import data with a simple insert statement. Previously, when I was at my last place, we were doing like Flink and Spark, and it takes effort to set up the jobs with the insert. You can just do insert and then select from any data source that's connected in Trino, like Postgres, Hive, Kafka even, Bootstrap new data sets. So if you have like a real-time table and then you have historical data in Hive or any other connector, you can just import it with an insert statement and use an ETL framework. And the same with backfill, like if you add a new column or you sanitize data, if you use Lambda architecture or you have the real-time data coming in and then you for example, have like a credit card company and then 2 months later they change your discount code or something and you want to rehydrate the data, you can just use a backfill, which is as simple as an insert statement that you'd be familiar with, with any ETL framework that you use. And then hydrating data, what it means is if the data's thirsty, bad hydrating joke. Joining the data with like complex other data, like for example, if you want one common use case that we had was where we would query Pinot to do anomaly detection and then do some filtered aggregation, like count where, some bad condition happens. And then another is to leverage the power of both Pinot and Trino together with table functions, which I'll demonstrate, where you can actually push an entire Pinot query and get the power of like the Pinot UDFs and Trino functions and all the other stuff that Martin mentioned, like match recognize and window functions, and I'll be giving a demo with that. Just to quick, probably this happened like 5 times already today, but just to go over like the Pinot architecture, there's the broker that's like the query endpoint, and then you have like real-time and offline servers. That's the main relevant parts for the connector. And the segment store, now you have deep store, which means you can store the Pinot data in like S3 or Azure or Google file system, so it could be recovered, or if a server crashes, it can download the data from the object store. And then now we get into the Pinot connector, how it works. So the first query path is directly to the servers, and we use the gRPC endpoint in Pinot. So one thing that I would hear a lot is there were other real-time systems that were really good at exporting, and actually with Pinot and gRPC you can get a huge select. So if you have like a feature set or some ML data set or just any large data set that you want to export, you can use the gRPC client, and that will prevent the servers from crashing. The legacy client would use, it builds the entire result set in memory and then sends it. With the gRPC client, it does gRPC streaming. So we leverage that logic in the Pinot connector. If you're just doing a simple select and just want the results really fast, then it handles like the time boundary, where you have like the real time and then offline minus 24 hours. And then the other type of query is a broker query, where let's say you want to do an aggregation. It's way more efficient to push it down to Pinot and then leverage like StarTree indexes and how the brokers aggregate all the data from the servers. And then you can also use like Pinot specific UDFs wrapped in a table function, which I'll demonstrate. And those queries are super low latency because they leverage like some of the cool features of Pinot, like star trees. So yeah, just to explain a little more about the gRPC streaming client. So you stream directly from the servers. It completely bypasses the broker. So if you had some huge data set and you wanted to do like training or something like that, if you did it through the broker, that's a single node. If you use the gRPC server client, then you get the data from all the servers in parallel to all the Trino workers in parallel. And that also avoids memory pressure on the Pinot servers because you're streaming the data. You're not building it up and then shipping it over. And then here we go to the demo. So this is querying the Chicago taxi cab data set. There was a thing on Kaggle about it, so I just downloaded a month of the data on this laptop, and the demo does, oh, now we go, sorry. Thank you. Good. So let me just make the font a little bit bigger. So this will show how we actually, like a mock scenario of inserting data and then querying the data. So now I will start up the, we already have Pinot running, sorry. And this should only take a second. Okay, good. So now I'm going to just copy and paste statements from this. This is a raw demo.
Make it bigger, Elon.
So this is something, there's an open PR for this, but where I worked, and I see somebody else in the audience that I worked with, we've been using it in production for over a year, maybe even like a year and a half. So let's say you have this data set in Hive. For this example, I just imported it as a CSV from like chicago.gov to Postgres, and then we hooked up Postgres and Pinot to Trino. So I'll just do an insert here. You can see it's running. It's almost done. Drum roll. Should be done soon. Just suspense. And it finished. Okay, so then we can get into the queries. So this, this is much easier than, for example, we initially were using Flink and then getting data from Trino and importing it into Pinot, but then you're limited just by the coordinator because it's like a JDBC to one endpoint. With this insert, what it does is it shards the data across the workers and splits it up. And it splits it up amongst the workers so that each worker gets like a specific subset of the data. So now let's say you're a data engineer and you just imported the data into Pinot. So now you want to select count. What this will do is actually push down the count to the brokers. So finish really fast, and then just to give a data quality. Yeah, I'll make the font bigger. So this is in Postgres. You can see that the counts match, but I'll go back to Trino here. Okay, and then another one, this is also going to be pushed to the broker because it's an aggregate, so it's much more efficient than, you see it came back in like 170 milliseconds. It's much more efficient than getting all the data from the Pinot servers and doing the aggregation. In Trino, it actually pushes the aggregation down to Pinot. So now, just to do a filter, so this also will leverage a Pinot inverted index.
Can everyone see?
Can you guys see, or should I make it more larger?
Yeah, make it larger so
okay.
everyone can see better.
So this, it pushes the filter into Pinot, and that will, and it's still using the gRPC client because it's not an aggregate, and but it does leverage the Pinot inverted indexes, or if you have Bloom filters on your tables. And so now we get to a new feature. This is something unique to Trino. It's called a table function, and what it does is you can actually push a Pinot query into Trino, and it, like for example this query, and it should match the results from the other query. That was a simple example. We'll get into some more. A table, so that here's a query where you have a table function and then you have the filter outside of it. It will actually push the filter into the function. Again, you have the same result. So now let's say you are exploring this data. So you found out, you see here, trip duration is 0, but the fare is greater than 0. So maybe this taxi cab company is ripping customers off. So now you need to do an investigation because the government of Chicago is, tasking you with fixing the corrupt taxi industry of Chicago. So first we'll just verify that some sane data exists also, where the end timestamp is greater than the start timestamp, and just to see, and then you do see that there is some valid trips where the fare is greater than 0 and the trip was also greater than 0 seconds. So now here's an example where you can use a table function. So this in the quotes, this is actually Pinot syntax, and it's the same query just pushed into Pinot, where you can, you just want to look at the data now before you get into your court case of SQL queries that will clean up the industry. So here's, I just want to give another example of, this is a Pinot date time convert function, so that there's no way you could execute this from Trino or Spark or anything without this feature, table functions. So this actually pushes that into the query, and you can see that it converted the column name is long, but it converted the interval into seconds. So now you want to find some invalid data. So this is where you can see that the trip total is like the amount it costs, but the duration was 0. And so now you want to find out who are the top offenders. I'll skip that one just because, so you can see this one uses a halving clause. It just shows, so this is an example where you're using a filtered aggregation, which is unique to Trino, and then it actually pushes the group by and the halving into Pinot, and you could see that the invalid trips, meaning like that the trip was like the timestamp, there was 0 seconds, but the fare was greater than 0. So the taxi affiliated services would owe customers $323,000. So you can, and do the order by, and you could find the top offenders like that. And then another example of this is an example of an aggregation that's unique to Trino Max Buy, where you get the max, like the company that's associated with the max trip total. So you can see that Globe Taxi is the most popular taxi company in that month of data that I exported from Chicago. Here's another example of a Pinot-only UDF aggregate function, percentile EST, like estimated percentile, and it'll push this directly into Pinot. And then now you have an example of a window function over a Pinot table. So this is where you can do the Pinot query, leverage the filter and fast aggregation, and then in Trino do processing on top of that. This just shows, what are the. It was just an example of a window function using rank. Let's see, yeah. And then another example, and we'll take questions. This is where, let's say you have some table in Postgres, you do a subquery and then you want to join it to Pinot, and like anything that you connect in Trino, you can do this with. So this will connect to both Postgres and Pinot. It was like a fabricated query. It just shows like the different, using histogram to show the payment types and the count of trips and join it between Postgres and Pinot. So that's pretty much the demo, but if anybody has questions, or do you want me to do some more window functions? Yeah, go ahead. What's your question?
Yeah. So Pinot itself does not give window aggregations, right? So how does the computation model look like? Do you pull data from Pinot and
Yeah.
Because Pinot itself doesn't really give you, like I cannot really do a select star on Pinot, and then, so does the connector actually just directly go to the segments and do its thing, or does it still use Pinot first to query?
So first it will use Pinot, and if it can push anything down into Pinot, it will. And then beyond that, like a window function processing happens after the regular parts of the query, like the aggregations happen. So that's when the Trino will use that data in the window function. Or if you have, like other things in Trino, like for example, like the count with like filtered aggregations, it'll do that part in Trino. So it'll try to push down as much as it can, like filters and just regular aggregations like max, min, count, even the approximate distinct, which maps to Pinot's distinct count HLL. If you need actual custom Pinot aggregations or a Pinot query, you can put it in the table function. And another use of this is where Pinot has, it handles null values differently than Trino does. So let's say you have a specific thing where you know that you have null handling enabled in a Pinot table, and you want to do like select something where it's null. In Trino that wouldn't work because the null value in Pinot is just going to be like the default value of the column. So you can wrap it in a table function, get the output of that, and then anything you do with that data will be, like the behavior will be consistent, so you get the best of both worlds.
Oh, thanks.
Yep. Yes?
The question is about the table function. So as an end user, the more choices you give, the chances are that they can end up writing a bad query. So other than using a specific Pinot syntax, why would you expose this system table function? Is there an optimization limit, or what is the reason?
Good question. So that's actually the reason for the table function is when you have no other way to get the data, or like let's say there's some new awesome like theta sketch. I think that guy Locks wrote that and contributed to Pinot, just for example. So there's no other way to get this Pinot UDF like with regular SQL. You can actually push the query down, and yeah, it gives you a lot of power, but yeah, with great power comes great responsibility. but you can also do, if you do simple aggregations where, like count, max, min, sum, average, even approximate, distinct, that will actually construct a Pinot query, go to the broker and leverage Pinot still. So it won't be pulling all the data and then counting it, it'll still be pushing it. And yeah, that's safer because you can't just write like a syntax error or something like that. But this gives you the power of Pinot, where there's no other way to get the data, or you want to use the custom null semantics of Pinot, but then get consistent results when you join it to other data sets.
It's an
But
escape.
performance-wise, will there be a difference between the two?
Actually, like whether you push the data, because both, let's say you're doing an aggregation, it'll construct a broker query, send it to the broker, and then you get the results back in the same amount of time that you would if you put it in a table function. It actually goes through the exact same code path. The advantage, though, of the table function is the flexibility. The advantage of just using regular, like without the table function, just relying on Trino to push it down, is that you get like the safety of that, like there won't be like a syntax error where you might put an extra comma or something.
So I would say at a given point in time, Trino and the connector support a set of optimizations, and the connector may know how to push down some of those parts of the query into Pinot, but if something gets added to Pinot, then it needs to be coded into the connector to be able to understand that if there's a new function with certain semantics, someone needs to write the code in the connector. So while that's happening, you have the escape hatch of being able to run that query faster in Pinot. And if that functionality makes it into the connector, then you can just switch back to using regular SQL in Trino.
Thank you.
Thank you for the talk. My question is, if you've tested the Trino Pinot connector with the V2 query engine, and if so, have done any performance tests between, like when executing joins?
Not yet, but I was talking to Jiang Fu, and we were planning on doing that. And yeah, it might actually be like a different code path because the V2 engine has different API. So, but we're planning on working on that. So in the future, yes. Oh yeah.
Okay, so basically, whereas what I'm saying is like once the V2 query engine is in place, we can actually push down some of the drawings from the Trino to Pinot. If it's like, for example, like dynamic filtering or collocated drawing, those kind of things we can optimize on the Pinot side. Then we will do that in Pinot side, and if it's like a cross data source or much more complex or advanced queries, we will still use Trino for that.
You had a lot of awesome examples, like common table expressions. Do you have examples of? Do you guys support CTEs?
Yeah. Yeah, that's part of the SQL. So it's part of the SQL standard. Trino implements ANSI SQL, basically, a big chunk of the specification, and that's one of the features it supports. So you can do with table name as a subquery, and then you use that in the rest of your query.
Okay, thank you.
What mechanism is the insert statement using in the Pinot side?
So it actually uses the Pinot libraries, the same ones that are in the minion jobs, to build the segments. And what it does is when you have incoming rows, it uses in Trino, it uses this logic to, if you have the table partitioned on a time column, it'll get the number of workers and then shard like the time column to a specific worker. and so that it could chunk the data. So if, there's a config option to set like, the recommended size of a segment, let's say like 450 megs. So it'll build up each segment, 450 megs uploaded, and it uses the metadata API to do that if you have deep store enabled. If you don't, it'll just upload it to the controller, which is like an older API. But just, from experience of running it also, using the metadata API is like an order of magnitude more efficient and stable, and it doesn't like put as much load on the controller because you're uploading the data to deep store. And it uses the Pinot library, so it's mostly disk-based. Even the sort is disk-based, so it doesn't use that much memory, and we recommend having an SSD. We actually did tests between TempFS versus an SSD. The SSD was an order of magnitude faster. It was like 400 megs a second, like almost the max speed of the SSD. Then it uploads it to S3, and it uses the start and end replace API so that if the insert fails, it just ignores, it won't do the end replace, or if the end replace fails, it'll automatically delete the segments so that you won't have extra disk space.
Thanks.
Can you end up with a duplicate data if you do this with the insert and in the same time someone is streaming data to Pinot?
I'm sorry, can you say it again?
Can you end up with duplicate data if you build the segments yourself with the insert query and at the same time someone is streaming data to Pinot?
Well, if you're streaming data to Pinot, it'll be in the real-time table, and then if you insert it, it'll be in the offline table. And if it's, there's a time boundary. It's like the most recent offline data minus 24 hours. So if the data overlaps there won't be duplicate data. But if you do two segments, there's a config option where you could say append only or overwrite. And if you have it as set as append only, then you will have duplicate data. If you have overwrite, then the one that completes last will be the winner, the data that you'll see. So you do have to be careful about like don't run two insert. Like if you have like what is it, Argo or Airflow or whatever ETL framework you use, just be careful to make sure you don't use, because if you run two inserts, it'll be just like doing two inserts to Postgres or something like that. Like one of them will win, and then depending on whether you do append, you'll have duplicate data, or overwrite, you'll have like the one that finished last.
Okay, and one Trino question. Do you guys plan any transactional supports in Trino? Like adding transactional capabilities to it?
So Trino support, it has support for transactions, but it's not, I would say it's very limited. And the challenge there is that it's a federated system, so you need to be able to talk to different data sources that may not cooperate with each other. So having a distributed transaction is super complicated. But for a limited set of connectors, it can actually do transactions. Say begin transaction, insert into table, commit, and that will be published in a single operation. I think the Hive connector is the one that supports that. I don't think we've added it for any other.
Hive is actually semi-transactional. It's not fully transactional.
Yeah.
And just to add a little context, the insert in Pinot is atomic, but there's no notion of a transaction there.
Right. So that one of the things that in general Trino will do is if you perform an operation like that, it will either complete or fail, and you shouldn't see any effects from the failure. So if you're for example, if you're dealing with Iceberg or Delta Lake, if you do an insert and the insert fails, any data that was partially written will be eventually garbage collected. It won't show up. It won't be visible. So it's atomic in that sense.
Okay, thank you.
Well, thanks everyone for joining. And by the way, so tomorrow, if you want to stop by the Starburst booth, there's some swag if you want to get that. And thanks everyone for coming.